Welcome to part 2 of our discussion of dissolution analysis added to Statgraphics version 20. I have divided the discussion of dissolution analysis into 3 videos. Part 1 had to do with fitting dissolution models to data from standard dissolution studies. This part 2, has to do with comparing the profiles of a test and a reference batch based on the models that were fit to those batches. Part 3 will cover making comparisons without fitting any models. The data we'll be looking at today comes from 1 reference batch and 5 test batches. Measurements were taken at 4 different time periods, 30, 60, 90, and 180 minutes. At each time period, data were collected for 12 different units. The data for each unit have been placed in a separate column. To run the comparisons in Statgraphics version 20, you select Relate from the top menu, and near the far right in the Dissolution Analysis section, select Model Dependent Comparisons. The first dialog box you'll see asks how your data is formatted. In this case, the data from different units have been placed in multiple data columns. On the next dialog box, you'll specify the column containing batch identifiers, the column containing the time periods, and multiple columns containing the measurements from the different units. When the Analysis Options dialog box appears, you specify the models to be fit to each of the batches. You can use the same model for all of the batches, or specify specific models for different batches by pushing the Select button. You also indicate whether the maximum dissolution parameter should be estimated from the data or specified by the user. In this case, I'm going to ask that we use the best models that we obtained in part 1 for each of the 6 batches. The Hopfenberg model will be used for the reference batch and test 1. The Weibel model will be used for test 2 and test 3, and the Gompertz model will be used for test 4 and test 5. Here you see the output generated by the model-dependent comparisons procedure. In the top part of the output, you see the models that were fit to the reference batch and the 5 test batches. You see the parameters, including the rate parameter, the second parameter, and the maximum dissolution parameter. You also see the R-squared and adjusted R-squared statistics that were calculated for each of those 6 models. In the lower half of the output, you see a comparison of each test batch with the reference batch. The primary statistic here is MAXDEV. That's the maximum deviation or maximum difference between the dissolution profiles of the reference batch and the test batch over a specified time period. In this case, the MAXDEV time range was set to be the range of the data, which was 30 to 180 minutes. You also see on the far right the lower and upper 90% MAXDEV bootstrap limits. The MAXDEV statistic is the maximum absolute difference between the models for the test and reference batches over a specified range of time. Asserting equivalence between the test and reference batches typically requires that MAXDEV be less than or equal to 10. Analysis options lets you specify the range of time over which you compute MAXDEV. By default, it's set to the time range contained in the data. You can also specify various aspects of the bootstrap confidence interval, including the number of subsamples. If you want to be sure you can replicate the exact same results by generating the same random numbers if you rerun the data, check the box that says Fix Random Seed. To calculate confidence limits for MAXDEV, bootstrapping is used. In bootstrapping, multiple samples are created by selecting observations with replacement from the test and reference batches. The value of MAXDEV is calculated for each subsample. The 5th and 95th percentiles of the bootstrap MAXDEV values form the confidence interval. Equivalence between the test and reference batches is asserted if the upper 90% confidence limit is less than or equal to 10. In this case, the only test batch for which the upper limit is less than or equal to 10 is test 1. So it is the only test batch that is equivalent to the reference batch at the 5% significance level. In part 3 of these videos, we will discuss methods for comparing batches without fitting any parametric models.